Hello guys. Because some of you were not in the classroom yesterday, and also we didn't manage to finish all the questions in class. So I'm going to make a video on this paper, stats paper 51. So the first question, to find the number of arrangements of the 8 letters here, and then in which all E's are all together and 2D's are together. As we did before, if they say all E's are together, D's are together, we can actually put all E's in a bag, like in a circle, and then 2D in a circle. And the rest of the letter we have, how many we have left? We have C, we have I, we have E, V, the other 3 letters left. So now we just need to arrange these letters together. So because we put this 3 in a bag or in a circle, this one in a circle, then that means I can just count this one as 1. Okay, so then how many arrangements do we have if we try to like permutate 1, 2, 3, 4, 5 items? So that's 5 factorial or 5p5. So this one equals to, what is it equal to? 120. And also because this one is, if you have different order, it doesn't matter because they are all the same item. D is the same. Question B, the number of different arrangements of 8 letters in this one, in which the 3 letters are not all together. So how can we do this one? If we try to find all 3's are not all together, that means the possibility is like E, like all separate, or might have 2E together, another E separate. That means they're not all together, but it's kind of difficult to think about. But what we could do is we can think about the opposite way. What is the opposite of not all together? So that means the opposite of that is all E's are together. So three E's are together, are all together. So if 3's are all together, we could just find the number of arrangements 3's are all together, and then we use the total amount of arrangements, like without like restrictions. We don't have any restriction. What is the total amount? And subtract 3's are all together. That is arrangements 3's are not all together. So what we need to do, first we need to figure out if there's no restrictions. If there's no restriction, how many different ways we can arrange the 8 letters over here? It's super easy, right? We know 8 letters. If we have D1, D2, E1, E2, E3, then actually we treat all these letters differently. So we can just use 8 factorial or like 8p8, the same thing. And then because they have repetition inside, so 2Ds, they repeat themselves amongst themselves 2 factorial ways. We need to divide by 2 factorial. But E's, they repeat themselves amongst themselves by 3 factorial ways. So we divide by 3 factorial. That's the total amount of arrangements for like without any restrictions. But now, if we thinking about 3E's are all together, it's similar to question A, we can put 3E's in a bag. And then what do we have left? We have 2D, and then we have C, I, V left. So now, because the restrictions only 3E's are together, right? Now we just put 3E like in a bag. Then we have like 1 item, 2, 3, 4, 5, 6. 6 items left. So we can just treat this one as D1, D2, then that means 6 items, we have 6 factorial way. But because we have repetition inside, D1 and D2 are exactly the same item. So they repeat themselves amongst themselves by 2 factorial ways. So we can find the total arrangements is 6 factorial minus divided by 2 factorial. So we can just use this one, the total amount, subtract this one, which I think is supposed to equal to 3360 minus 360, which is 3000. Okay, question 2. There are 6 men and 8 women in a book club. The committee of the club consists of 5 members. Mr. Lan and Mrs. Lan are members of the club. In how many different ways can committee be selected if exactly one of the Mr. Lan and Mrs. Lan must be in the committee? Okay, because the restriction here is exactly one of them. So there are 2 scenarios. One is Mr. Lan in the committee. How many people in the committee? 5. So committee made up of 5. So you have another 1, 2, 3, 4. Second scenario is Mrs. Lan in the committee, but Mr. Lan is not. So that's 2 different scenarios. And also, you need to understand the question. What does select mean? Select means order doesn't matter, right? You just need to find how many different selections we have, like makeup of the committee. So you need to select another 4 people from this. But remember, Mr. Lan inside Mrs. Lan can't be in the committee because they have exactly 1 in the committee. So that means we take out Mrs. Lan out from the total amount and also Mr. Lan because you already take him out. So you actually have 5 men left and 7 women left. So you have 12 people, choose 4 ways to make the committee. And then this one, similar, you still have 5 men, 5 women because you have Mrs. Lan here, Mr. Lan can't be in. So you have 12 select 4. So basically you can just use this 12 select 4 times 2. I think the answer is, what's that? 999. Okay. Then question B, in how many different ways can committee be selected if Mrs. Lan must be on the committee and there must be more women than men on the committee? Okay. So they said Mrs. Lan must be in the committee. Mrs. Lan is chosen and there's 1, 2, 3, 4. So 4 people to be selected. So now the restriction is there must be more women than men. They didn't say anything about Mr. Lan. So how many people we have left? We have in total we have 6 men. We have 6 men, and then we have, except Mrs. Lan, we have 7 women left. So now we need to consider these 4 people. How many men and how many women we can select? Okay, so we just look at, because women needs to be more than men. So we just think about if we choose all women, no men, that definitely meets the question. And then if we have 3 women, 1 man, that also meets the requirements. And then we could also have 2 women, 2 men, plus Mrs. Lan, we have 3 women. It's still more than men, 2 men. But if we have 1 woman, 3 men, that means it doesn't meet because it's women start less than like men. So you actually have 3 scenarios to think about. First, you choose 4 women, 0 men. So you need to choose 4 from 7. That's the first scenario. Second one is you choose 1 man, 6 choose 1 times 7 choose 3. And then the third scenario is this one. So you choose 6 choose 2 times 7 choose 2. And then you add that up. I think your final answer is going to be 560. Okay, that's question 2. Question 3. You need to draw a histogram to repeat the information, to represent the information. If you want to draw a histogram, you must have frequency density. Frequency density actually equal to the frequency divided by class width. Oh, this question over here. The class width is continuous in this question. We did another past example. When the given class width is not continuous, you need to subtract 0.5 from the lower boundary and plus 0.5 for the up boundary to make the class width to be continuous. And then we need to use a new class, use a frequency divided by the new class width to find the frequency density. In this case, the class width is 20, 10, 10, 20, and 30. So this one divided by this one, 22. This one by divided 72, and this one divided by this one is 92. This one is 15. This one is 4. Okay. Then we need to draw an histogram. So our x-axis is supposed to be the, what's that? Class width is time taken. So write your title, time taken, which is I think is minutes, right? Yeah, minutes. Time taken in minutes. And so y-axis is the frequency density. And then what we have over here, where do we start? We start from 0. Okay, we just put this one as 0, and our class width is up to 90. So we might just choose this one. 10 is too small. 20. This one is 40, then 60, 80, 100. Then the y-axis, we have a look, is 22 up to 92. Then we might just use 92, so 20, 40, 60, 80, 100. Then the first one, in the first class is 22. Okay, because there's 10 grades over here. 10, it's 20, so 20 divided by 10 is 2. So each grade represents 2. So 22 is going to be here. That's your first 22. And then second one is 72. 72 is going to be, this one is 60, 70, 72 is over here. I forgot what is the class width, is 230. Where's 30? Halfway through this one. It's going to be here. Oh, sorry. I'm supposed to draw a straight line. In the test, in the exam, you probably use a ruler to draw it. And then next one is 92. The class width is 30 to 40. 92, 90 is in between here, and 92 is this one. Okay. Sorry. Then next one is 15. But what's our class width? I forgot. Class width is 40 to 60, 15. So 10 is over here, 14. So in between this one, in between this is 15. And the last one is 4. Okay. 4 to 90. Okay, 4 is over here. That's our histogram. Then second question, from the data set, you need to find the estimate mean t is 30.4. The question is already give you the estimate mean, but you should be able to calculate estimate mean from the given information. So if you remember if we want to find the mean for the group data, the formula is we use so we need to find our middle points, middle value, or middle points in each class width. So this middle is 0 plus 20 divided by 2, which is 10. This middle value is 20 plus 30 divided by 2 is 25. And this one plus this one divided by 2 is 35. And this one is 50. This one is 75. That's the middle value for each group data. When you calculate the estimated mean, you need to use a middle value to represent each data, and then so that you need to add all this data up, because the frequency means you have number 10 occurred like 440 times. So you need to use 440 times 10, and then 720 times 25, and add all this up. So use the middle value. This is the middle value, middle points value times the frequency, and then you divide by the total frequency. In this case, the final value is 31.444. And the question asks us to find the standard deviation. Okay, so this is given. We don't need to worry about it. So now we try to calculate the standard deviation. Standard deviation actually equal to square root of the variance. The variance formula for grouped data is we use the sum of each data squared. So that data we still use middle point to estimate. So x squared times the frequency, and then we divide by total frequency, and then subtract our mean squared. So in this case, it's pretty easy. You just need to square each number over here. 10 squared is 100. This one squared is 25 squared is 625, and then you square this one, square this one, square this one, and then use frequency times this one. So your standard deviation is going to be a long one. It's going to be 10 squared times 440 plus 25 squared times 720 plus 35 squared times 920 plus 50 squared times 300 plus 75 squared times 120, and then you divide by total frequency is 2500, and subtract the mean squared is 31.44 squared, and you put in your calculator. If you put in your calculator, you're supposed to get the value 229.26. Yeah. Okay. That's for question B, 3B. And then question C asks you which class width does the up quartile lies? Okay. Remember, how do we calculate up quartile? So if you look at this one, up quartile, the total amount of data is 2,500. That means we need to look at the data. If you divide this, because it's even number, if you divide by 2, it is 1,250 data before, and another one is another part is also the same 1,250, and then the up quartile is the middle of the second half. So the second half is still even number, and then the middle of this one is going to be 2 number, right? So is this one divided by 2, 625. So it is 625's number and also 626 number. This 2 number plus together divided by 2, that's your up quartile. Similar way, you can find your lower quartile, and also the mean the median is you just divide this even number by 2, which is this one. So that means your mean is this number and this number you plus together divide by 2. Now we calculate the upper quartile. Upper quartile, you need to find this 2 number. Okay, we look at the frequency. The first 440 number is here in this range, and then next number is going to be oh, sorry, I did mistake, because this one is just to look at the second half. You still have the first, because upper quartile is you add on the before, because it's 75% of data. So this number, first half plus this one, it becomes to 1,875 and 1,876. Okay, so you plus this 2, you got 1,160. That means this 2 data definitely adds in the interval class width of this one. So is this question is pretty straightforward. So it's between this one, the class width of this one. Then it was later discovered that the times taken to travel to college by 2 students were incorrectly recorded. The students recorded as 15 instead of 5, and the other student's time was recorded 65 instead of 75. Without any further calculation, state a reason whether the estimated standard deviation would be increased, decreased, or stay the same. So this question, if you want to answer the question, you need to look at how do we calculate the standard deviation, right? Standard deviation was a little bit formula over here. So we use the middle point value to estimate the answer. And this is the estimated mean. Okay, so we look at this too. 15 instead of 5. If 15 instead of 5, 15 and 5 both in this category, in the first class width. So that means if they are staying in the same class width, the middle point value to represent their value, it doesn't change anything. They still use the same middle point value 10 to represent that. And then the other one is 65 instead of 75. 65 and 75 both in this category. So the middle point value doesn't change. That means the mean doesn't change. And also if middle point doesn't change, the standard deviation calculation, this part also doesn't change. So that means we will get exactly the same answer. So that means they stays the same. They will stay exactly the same because they stay in the same class width. Okay, question 4. Jack Boo has 4 coins. One of the coins is biased such that when it is throwing, the probability of obtaining a head is this one. The other 3 are fair coin. So Jack Boo throws all 4 coins once. The number of heads he obtained is denoted by the random variable x. The probability distribution like this way. Okay, we just look at this one. 4 dice, you have 1, dice 1, dice 2, dice 3, dice 4. And then the first one, let's say, is a biased one. So you have one biased. And then the other one are fair dice. And now we're looking at the probability distribution for the number of heads they obtained. For example, if you throw this 4 dice once, the probability of getting heads, this one is 7/10, and this one is a half, this one is a half, this one's a half. The probability not getting a head, this one is 3/10, and this one's still a half. Okay, so show that A equal to 5/5, and then find the value of B and C. It's super easy, right? Because the first one is ask you to find the probability when you only have exactly 1 head. How can you calculate that? So first, you need to consider 1, 2, 3, 4, which one get head. So if the first one get head, okay, the rest you get tail. Okay, so that's one scenario, right? And then you could have the first one get tail and second one get head, and then the rest get tail. And then you could have another one. So first 2 tail, head, tail, and then first tail, head, like 4 scenarios. So the first one, the probability of getting the first one get hate is 7/10 times the rest is a half times a half times a half plus this one. If you see this one, these three are the same because this one getting a tail is 3/10, and then times getting a hate is a half, getting a tail still a half, and then you will see this one is exactly the same. So the first one not getting a hate is 3/10, and this one is a hate a half, and then you basically times 3. So finally you will figure out this one equal to 1/5. That's what you need to do to calculate A. Similarly, we can find 2 and 3. Okay, if you have like probably find x equal to, I think if you find the probability of x equal to 2, one-fifth for this one. Okay, how do you find 2? Same way, 2 hates. That means you could just use formula to do it. We have 2 different scenarios. One is first one, the biased one get hate. The other one is the biased one. So let's say this is a biased dice. Biased one. First scenario, this one get it. Second one is get a hate for the biased one, and the rest of them. So that means the rest of them must have 1 hate, and this one, the rest of them have 2 hates. Okay, so we can try to calculate the probability for the first scenario. The first one you get a hate is 7/10 times the rest of them. You have 1 of them get hate. So we have how many options do we have? We have 3 options for like any of this can get a hate. So we actually 3 choose 1. We have 3 different combination for this, and then times the probability of each is a half times another a half squared. Okay, and then plus this one, the first one is getting a tail, and then the rest of them, 2 of them need to get hate. So 3 choose 2 to get a hate, and then like the probability getting hate is a half squared times a half. After calculation, you will get this one equal to 1/8. So B equal to 1/8. How do we calculate C? C is going to be 1 minus the rest of them. So 3/80 minus 1/5 minus 1/8 minus 7/8. And finally, you got 3/10. Okay, that's for this one. Yeah, that's the right answer, I think. Hang on. Why I got wrong answer over here? Yeah, it is right. Maybe I calculate. Let me have a look. Oh yeah. Sorry, I copied down because I just calculated before. This one is 3/8, and this one C is still 3/10. That's right. Yeah. Find the expectation. Expected mean. Super easy, right? Expected mean. We'll just use a formula. We just need to use each number times its probability together. This is like a binomial distribution. So probably equal to each observed value times the probability. So in this case, it's going to be 0 times, what's that? 0 times 380 plus 1 times 1/5 plus 2 times 3/8 plus 3 times 3/10 plus 4 times, what's the last one? 780. What's the answer equal to? Can't remember. It's 22.2. Sorry, 2.2. That's question B. Done. Question C. Jack moves through all 4 points 10 times. That's a typical binomial distribution, right? So 10 times, you need to find the probability he obtains exactly one head on fewer than 3 occasions. Okay, fewer than 3 occasions. So that means you get this one 10 times. You need to find the probability like less than 3 times they will get exactly one head. So first of all, we need to look at what is the probability. What is the probability? What is the probability he obtains exactly one head? Okay, if you look at the probability distribution before, the probability when he rolled the 4 dice once, the probability of getting exactly one head is 1/5. 1/5. That's the probability of getting a head. Okay, and also this independent, because every time you roll the 4 dice, so your probability of getting exactly one head is always 1/5. So that means this variable here, we can define it. This x actually is binomially distributed by the number of tries 10, and the probability of getting success, or the probability of getting exactly one head, is 1/5. Its probability of not getting one head is the opposite, is 4/5. Okay, now they ask us calculate the probability. They get success like this probability, right? Getting exactly one head is less than 3 occasion. That means we need to find less than 3. So now what does less than 3 mean? That means we need to calculate 0. So never, we didn't get any scenario like any of them, none of them get 0. No, none of them get exactly one head. And then over the 10 times, and then the probability of 1 over the 10 times, only one time they get exactly one head. And then over the 10 times experiment, they only have 2 times they get exactly one head. So now we just use binomial distribution like probability formula, which is 0. So that means over 10 times, we just choose 0 times to get success. So 0 times success is the success. Probability times to the power 0 times the failure, probability of 10. And then plus 10 times, you have 1 time you got success times this one to the power 1, and then times the failure, you got 9 times failure. And then plus this one is 10 choose 2 times this one, 2 success times the failure, 8 times. Okay. So finally, if you calculate this answer, what's that equal to? I think it equal to what's that? Yeah, it's equal to, say, 0.678. 0.678. Yeah, that's right. Okay, next one. Find the probability that Jack obtains exact one head for the first time on 7th, for the first time on the 7th, or 8th time that he throws the 4 coins. Okay, so if you look at the word, the first time he get it, so he got exactly one head on the 7th time or 8th time. That's typically is talking about geometric distribution. So for example, they're talking about x is geometric distributed and the probability of success. Success is still 1/5, is that right? because like every time they're getting a hit is the probability of getting exactly one hit is 1/5, because they're asking for the first time they get it. So we use geometry distribution to model the situation. So now they ask the probability of when x equal to 7, so they get success on the 7th time, and plus the probability of an x equal to 8th time. So this one is pretty easy because geometry distribution means if you get your success on the 7th try, right? That means the first 6 try you all got failure. So failure probability is 1 minus a half of a fifth. Excuse me. 1 minus 1/5 is 4/5 to the power 6. The 7th try would get success. And this one is 4/5 to the power of 7 times 1/5, which equals to, what's the answer? I can't remember. Sorry, it's 0.678. That's your final answer. Question 5 is normal distribution. We haven't done that, so ignore this one. That will not be tested in the end of the exam. So question 6, last one. Okay, Janice is playing a computer game, and she has to. Okay, so she has to complete level 1 and 2 to finish the game. She is allowed to at most 2 attempts at any level. So for level 1, probably that Janice complete it for the first attempt. So first attempt success is 0.6 probability. If she fails first attempt, the probability she attempts a second try success. She completes it. It means you success. The probability is lower, is 0.3. Okay. Then if Janice completes level 1, she immediately moves on to level 2. Okay. So then for level 2, the probability Janice completes it at the first attempt is 0.4. But if she fails for the first one, then the probability she completes at the second attempt is only 0.2. So now you need to show the probability Janice moves to on the first from level 2. Okay, let's discuss like how can she move to level 2. One way is she directly pass level 1. Okay, directly pass level 1. Okay, second fail level 1, and then he passed level 1 in the second try. Okay, so we need to calculate the probability of both of this. What is the probability of passing level 1 on the first time? What's that? Okay, the probability of passing the second is 0.6. Okay, that's the probability for this one. And the probability for failure, this is 0.6. And this one, for failure, that means 0.4. Failure first, and then success. So what's the probability for success? Is when they failed for this one, the second time they attempted the success is 0.3. So you just calculate this one is 0.72. Pretty straightforward, either ones. Okay, find the probability Janice finish again. Okay, how? We just need to analyze how she can finish the game. She might finish again first time, pass, and then he directly go to level 2, and then he can go to level 2 directly pass, or failure and then pass. That's one way. And then the first time he might fail, and then after he fails, the second time he must be pass, right? If he's failed, that game over. And then if he pass for the second time, and then we look at the rest. So second level 2. For level 2, he can directly pass, or he might fail or go to second attempt and then pass. So it's like different scenario. Okay, we need to calculate the probability. What's the probability for this? The probability he got first time 0.6. That's the success first time. And then times the probability of this. Okay, I actually can times together, but I can also calculate it individually because I need to add this one and this one together. What's the probability for this one? Probability directly success is 0.4. So it's all right. Hang on. We could. I think I made it complicated. Is that right? Because we only need to look at, for example, the first time he passed, and then first time pass, then okay, the probability of yeah, sorry guys, I made it complicated. So what we can do in this question, we can use this one to make it less complicated. So because we already know the probability he moves to level 2 is 0.72. Is that right? Ignore this complicated calculation because we already know the probability he passed level 1. So pass level 1 is 0.72. Now we just need to look at two scenario. Because he already moved to level 2, one way he can do is directly pass level 2. It's all right. Pass level directly or fail and then pass. Okay, so then we just need to calculate. The first one is 0.72 times the probability of directly pass level 2 is 0.4. Is that right? Directly pass is 0.4 plus 0.7 times first times failure. So in this level 2 try, the first one he failure is 0. Opposite of this one. First time attempt in the level 2 is 0.4 success, that means 0.6 probability is failure, and then times the probability of what's that, the probability p is pass. Okay, second time pass is 0.2. Okay, we can just calculate this one. I think I did calculate it. It equals to 0.3744. I see. Guys, yeah, in the marking scheme, they still show this way. They have this way. You can use this one to do it, but I just feel like this one is easier to understand. That's why I just picked this one and ignore this one. This is the right way. If you look at the marking scheme, they have a second alternative way. It's my first thinking. Okay. Then question C, find the probability that Jennings failed exactly one attempt given that he finished the game. Okay, so actually they ask you find the conditional probability. Condition is he finished the game. Okay, finish the game. Okay, so now fails exactly one attempt. Fail one attempt only. Okay, so how do we calculate this one? We can use a formula. Is that right? So this one, we know this one is equal to probability of finish the game. Okay, divided by finish again, and then the probability of this one and this one. So finish the game and only fail one attempt. Okay, So now, which one is easier to calculate? Finish the gain, we already calculated, I think. Finish the gain is here, 0.344. So basically, I can just know this one is 744. We just need to find the probability that person finish the game and failure one attempt. Super easy, right? I think if you use this method, you already see it. So for example, if you use this method, you will see if they finish the game, what's the probability of like they finish the game and then only failure once. Okay, this is the one. And also this is one. This is not because they failure twice. Okay, you just need to find the probability of this plus probability of this. Let's just do it. So this one actually equal to probability of pass, level 1 pass, and then level 2 failure, and then second time level 2 pass, plus probability of failure for level 1, and then pass level 1 second time, and then level 2 directly pass. Okay, so we need to work out the probability for this. The probability of pass level 1 directly is 0.6 times the probability of the first time pass this one is 0.6. The first time pass level 1 is 0.4. That means failure the first time is 0.6. So we need to find this one, failure. The second one is 0.6 times the second time the failure is 0.2. Oh, sorry. The second time the directly success is 0.2 plus this one. The first time failure is so easy because the first time you success is 0.6. The opposite is 0.4 failure times this one. If you failure for the first time, the second time you attempt, the second attempt you success is 0.3. So you got 0.3 over here. And then times this one probability, this one is what's that? 0.3. Yeah, am I right? First one you failure and it's 0.3. That's right. Okay. Then the second for second one level 2, the direct success probability is 0.6. 0.4. Sorry, 0.4 over here. Okay. We can directly calculate this one. 6. I think I did calculation before, which is 0.12. And then my final probability for that one equal to 0.12 over 0.3744, which is 0.321. 321. Yeah. That's all for paper 51. If you have any other questions, feel free to message me on Teams. Tomorrow we are going to do 53. See you guys.